Hello everyone. Today we are going to talk about policy limit. Let's learn the definition of the policy limit. The policy limit is the maximum amount the insurer will pay for a single loss. So let X represent the loss variable. Note that X can never below 0, as negative values do not make sense in the context of loss amounts. Then for insurance with a policy limit mu, the insurance payment is defined as X capital mu. So when X is less than mu, the payment is X. When X is greater than or equal to mu, the payment is just mu, which implies the payment amount is the loss amount capital mu. In other words, the insurer pays whichever is lower the loss of the policy limit. X capital mu is also called the limited loss variables. And below is some of the formulas you will be provided in the exams. So this part is the formula. You don't need to be able to deduce it, but we are still going to talk about it in the next slide. Okay, here is the process to deduce the expected value for X capital mu and X capital mu raised to the power of K. The basic knowledge you should know is from the calculus, where you have this formula. Integral of u dv is equal uv minus integral of v du. So here in this process, x times fx, this is u dv, and this part is u times v, and this times v du. So once you understand that part, I think the rest is easier. I will not get into the details, but yes, you should know the basic knowledge about this, and the formula will be provided in the exam, but you still should understand the process. Okay, now we are going to talk about a special case when mu is approaching infinity. So just for remind you, previously we were talking about E x capital mu, which we already derived it as this x fx plus mu 1 minus f mu. So when mu is approaching infinity, it just means there's no limit. So ex should just be ex mu, when mu is basically just ex, because there's no limit is infinity. And in this case, if we look at the formula, 1 minus f mu will become 0, because f mu reaching infinity, this part will disappear, so it will just become the first part, where is 0 to infinity. Mu is infinity, x fx. So that's how you derive that part. Similarly for the second formula. And in general, if a random variable x is belong to a to infinity, then ex will be starting from a integral to infinity. So the final formula will become a plus this xx dx in integral from a to infinity. This is the general case. So first part is the special case when mu is infinity. The second part is the general case for the for the lower bound, if lower bound is not 0 rather than a, then the expectation will basically just raised by a. Is a plus this. Now let's look at an example. Loss amounts have a distribution whose density function is fx equal this, and x belongs to 0 and 100 interval. Insurance coverage on these losses has a policy limit of 60. Calculate the expected insurance payment per loss. So this is a simple application of the formula we learned earlier. Let me see. E cap at 60. If we are deduce it, will be like this: x fx plus 60 100 fx dx, or eventually it becomes this. This is the formula we learned in previous slide. Now all we need to do is find out Sx, then we can do the integral. So in order to find the Sx, we'll find Fx first, because Fx is 1 minus Sx. So Fx is equal this Ft dt, and Ft was given. So we can put Ft is 100 minus x dx. Now here there are different ways to do it. I think the easiest way is this. So this should be t here. Okay. Eventually you will get to here. Then Sx is just 1 minus Fx. So it will be 100 minus x 100. With Sx given, then you can calculate Ex 60. It's just integral of 60 Sx dx. I'm not going to go in detail, I'm running out of space, but eventually you will get this. So if you are not clear with process, you can look at the notes. It is slightly better written on my current handwriting. Example 2. Loss amounts follow a Pareto distribution with alpha equal 0.25, theta equal 100. Insurance coverage on the losses has a policy limit of 60. Calculate the expected insurance payment per loss. The formula is really already given in the exam sheet, so all you need to do is just apply the formula. Ex 1 minus theta so this is the one alpha. This is the formula in the spread in the exam sheet. So we just put it in, and then you get the result. Theta is 100. Alpha is 0.25. And the answer is 56.35. So earlier we talked about the situation when claim size is continuous, which is the normal case, and we derive the expected value for x capital mu and x capital mu raised to the case power. I put the formula on the right side of this slide, but now we are talking about a situation when claim size follows discrete distribution. Then you have to substitute the sums for integrals. So here is the formula for the discrete distribution. Expected value of x capital mu raised to k will become this plus this, which is similar, it's comparable to the right side. But there's another situation when x follows empirical distribution, then its limited expected value for k equal 1 can be just calculated as follows. Expected value of x capital mu can just be sigma xi capital mu. You sum it up from 1 to n. Basically, you sum up all the instances in this case and divide it by n. So next slide, we're going to give you an example. Now let's look at this example. A sample of 2000 claims contains 1700 that are no greater than 6000, 30 that are greater than 6000 but no greater than 7000, and 270 that are greater than 7000. The total amount of the 30 claims that are greater than 6000 but no greater than 7000 is 200,000. The empirical limited expected value function for this sample evaluated at 6000 is 1810. Determine the empirical limited expected value function for this sample evaluated at 7000. First, we write out all the information on the right. If it's less than 6000, there are 1700 of them. If the claim is 6000 to 7000, there are 30 of them, and the total is 200,000. And if the claim is more than 7000, there are 270 of them, so there are a total of 200 claims. So based on this information, first we know that if this policy limit is 6000, if policy limit is 6000, in the first group you will get X, but in the second group you will get only 6000, and the third group is the same, it will only get 6000. So based on this, we can write out the formula. First, this is given, then this part is less than 6000, we don't know the total, but this part, if it's greater than 6000, you will only get 6000. That's why it's 6000 times. This should be 270 plus 300, not 30 here. Then, based on this, we can get the first group has the average of 910. Now we have the with this, we also have the information for a second group, which has an expected value of 100. So we can calculate the expected value if the limit is 7000. So the first group you will get 910, the second group you will get 100, and the third group you will get 7000 times the possibility of this, which is 270 divided by 2000. You will get a total of 1955. So this is how we use the empirical formula for this purpose. Last, we are going to talk about inflation that is having an impact towards this policy limit. So this can be quickly derived using a mathematical functions. Suppose y is the claims after inflation, r is the inflation, then y is equal 1 plus r times x. Then expected value of y capital mu will become expected value of 1 plus r times x capital mu. If we switch 1 plus r to the other side of the equation and pull it out, you will get it's equal 1 plus r times e. Expected value of x capital mu divided by 1 plus r. This is the formula that we are going to use to solve the problem below. The Pareto distribution with parameters theta equal 12, 1,500 and alpha equal 2 appears to be a good fit to 2010 policy year liability claims. What's the estimated claim severity for a policy issue in 2018 with a 200,000 limit of liability, assume that inflation has been a constant of 5% per year. So we can write like this. Let me see. Here. Expected value will be 1 plus 0.5 times x cap at 200,000. Then this will be equal 1 plus 0.5, or let's the 8th power. This is because 2010 and to 2018 there are 8 years in between. Okay. Then this will become e x 200k divided by 1 plus 0.5 to the 8th. Then from here, the rest is just apply the formula using the Pareto distribution. You can look at the formula sheet. It gives you the how to calculate this Ex cap at mu. So I will not write out the rest, but you can check the final number to be this.